In the last video, we looked at the key features of a program or code written in C. So John, how does code get from the PC screen onto the microcontroller?
First of all, we need to put the RenBed board into a position where it can receive code, and we do that by pressing ISP, which is in-system serial programming. And we can confirm that we're in there because we've got a yellow light. So that's now ready. And what this does is it appears as a drive on your computer, so you can save files onto it, which is how you do the process of downloading and programming. So we go back to our original figure of 8 program. I've actually included a deliberate error on this one, because although C is very easy to read and it's quite easy to write, you do have to be very precise with your structure. If you get any errors, then the system's not going to know what it's doing, and you could end up with unexpected results. So this is caught at an early stage by the compiler. The compiler translates the English code into a machine code which is readable and understandable by the microcontroller, but you have to be exactly spot on what you actually want to achieve. So we've got an error in here, and we're going to hit compile. And what we're going to demonstrate is how we can use the compiler to help us find any errors. At the bottom, we've got a message which says it's expected a semicolon. And if we click on it, we can see that it's highlighted the line, and we've also got a stop sign saying where there was a problem. And we can look around the code, and normally it's either on that line or sometimes it could be just before. And we can see the line before, I've missed off a semicolon, which has caused it to think that the next one follows on from the previous line. So we can add our semicolon back in. And when we hit compile now, this should have now corrected all of the errors, allowing the compiler to do its work of translating the English structure into assembly language. And it's done that, and we end up with a .bin file, which is a binary file. And this is the code which the microprocessor uses. So we select Save As, and we look down our list of drives, and we can see one called CRP disabled, and CRP stands for Code Read Protect. So we can navigate there. We can see that there's a file in there already called firmware bin, and this is the code which was previously loaded onto RenBed. So we can select this, right click and delete it. And now we can save our new file into that space. Windows may come up and say that the file already exists. This is normal, and you just say, yes, we do want to replace it. And that's it. We've just compiled the program. That's converted it into machine language, which the microprocessor can understand, and we've downloaded it onto RenBuggy. So if we refit the batteries and press reset, RenBed will now drive RenBuggy in its figure of 8 course, which we saw in the previous video.
John, can you summarise for us why a program needs to be compiled before it's downloaded?
We mentioned earlier that there's a high-level language which we're using C, which is using a set of English instructions, and we need to convert that into machine language instructions. To put this into perspective, if we were to make a cup of tea, then you would think it as fill a kettle up, boil the water, pour it into a teacup, add a tea bag, add some milk, add sugar as required. We're doing the same thing by converting C into a program for a microprocessor, except we need to be very explicit about what it does. So we'll need to give it instructions on where the kettle is. Go to the kettle, pick up the kettle, take the kettle to the tap, then you have to turn the tap on, fill the kettle for a certain level. And you can see that you end up with a lot more detail and complexity being added to what we thought was a simple task. And the same is with C. We've got 6 lines of code there which drive the buggy into a figure of 8. We can see by going into one of the outputs, and we can see the build details, that this is turned into 7.5 kilobytes of machine code which the microprocessor can understand. And what that equates to is effectively 2,000 lines of code, or 40 sheets of A4.